So, hello everybody. Thank you for coming. The food time is here, but well, that will be a short story about the problems around an attempt to deploy some application. And the first thing I would ask you: do you understand what does it mean, the DevOps actually? So as long as we're speaking about the Opsless DevOps, well, let's try to figure out whether we understand this or not. Well, I hope everybody of us has some idea what it means, but I decided to have a look on Wikipedia first. And the thing I found there is something which is like explaining what I feel like. It is something like it's not the roles, it's more about the process, about how you build the whole thing together with some team. And in this talk, I'll be speaking about this story of some internal series which we've done and which is still alive. And the thing is here is that it is not always necessary to pick the best technology over there to implement something. At some point, you may use what you have at the moment to implement what you need. And in my case, it was an application which was hosted onto several data centers, not the clouds, but with the chances to be deployed to cloud. It was developed with JVM and Kotlin and a mixture of technologies. And it has active users, and so from several locations which are connected together. So it's kind of a standard thing, I guess, right? And the thing is that to deploy this one, we decided to use, well, that's a story for about 3 years ago. And by that time, it was really, really good idea to use the green-blue deployment. This is nothing actually special. The idea is like when we try to update the system, we set up the new version of our system along with the previous one, and then we make sure that state is moved there, and typically it's done with read-only mode. So we make the system read-only, we copy the state, we start the second system, and if it's go okay, we just switch the load balancer to run it. I hope it's not that something new here. The good part here is everybody is able to fail the update or something. And in that case, we say, OK, we can roll it back. Why? Because we have the older system running for us just behind the curtain. So it should be, well, just fine to turn back. And the picture might be like this. So we have the load balancer in the middle, and the one setup, the second setup, and it runs. And at some moment, we say, OK, we need to switch, so we turn the toggle, and it works the other side. And this is idea, by the way, it's not something really, really new. It's pretty old. This is a picture I found on a Martin Fowler blog and explaining exactly the same idea. Well, sometimes at some points we may say, OK, we are not setting up something really, really new. Instead, we're using the same hardware to actually host the 2 copies of our program. It depends if you have enough hardware to run the true copy or not. Or it depends on techniques which you have. And in my case, it was kind of not that Kubernetes, not that cloud. It was, we have Docker images to deploy to contain the application. Our Java application was compiled to Docker images, and we're running containers from the production. We tag these containers with the versions to make it bearable. And by that time, it was the most popular technology for us. Unfortunately, it was Ansible. Oh, are you using Ansible? Good. Using Terraform? Same hands. That's good. So the Ansible, it's YAML files, which actually runs via SSH on every host to do some bulk tasks. That was a good technique, at least by that time. And we implemented the green-blue technology with Ansible, so we're handling several hosts running with one Ansible scripts. And at that point, at least I realized that, OK, Ansible is good, but how would I run it? Actually, it's too hard to run because of the secrets, because of the keys, and so on. From the other side, at that point, it was, to me, it was clear that Ansible is something which stays here for some time because it is too hard to throw away the whole setup to build something new. It was not easy to build that setup. So I decided to say, OK, we used what we have, and we tried to improve and solve the pain points. And the first one was, how would I run my script? So I have the scripts, and actually I wasn't even able to run it locally because I don't have necessary keys on my machine. And should I share the keys for everybody? No, that doesn't sound good. Should I share the access to the Ansible repository to everybody? Well, it turned out that we created the repo at the first site with a credential, some keys inside it. You should not do this. You should manage the credentials some other way. But still, it was hard. And the idea was, OK, as long as we have continuous integration running for us, let's use it as a cockpit to start these Ansible scripts. So in TeamCity, we have the credentials, the keys, anything we need. And we technically start Ansible in a Docker container, which is the way to start it. So you no longer need to bother setting up the right Python version and so on. And this is what we had at the end, so at that time. So we have a TeamCity build configuration. So if I need to do some task, I can click a run button, and I start the build, which does the task for me. And it is more or less safe, because now all secrets are there. And TeamCity is able even to hide the passwords if you use it in some properties. So, and that was something what I use. So I just click a button here, I pick the backends I need to update, and it does it somehow. Sometimes it even not failing because of the Ansible scripts or the production as a whole thing, I mean. And at that point, I realized, OK, what we have at this moment? We have the TeamCity configurations, which we created manually with the mouse clicks. And it scales not that good. Say I have the second setup of my application. What I do? I had to copy the whole configurations manually. It's not the best thing to do. And to solve this one, I decided to switch to DSLs. Well, it is the way to declare the configurations with a script. In this case, we use Kotlin as a language to declare the configurations. So the idea is that TeamCity server executes the DSL code once to generate the pipeline to the execution graph. And then TeamCity server executes it. The second thing, it is possible to convert. So I had the existing configurations created manually. I clicked the button to create the DSLs. And so at the end, I was able to create the configurations with the function calls. So yeah, so this is how it works. And then we see the DSL. So after I have this DSL generated for me by TeamCity, I refactored it in a way to avoid the duplication things. So now to set up the new stack, the new setup of my program, what I did, I only call this function again with different host names and stuff. And that was it. Well, of course, it's clear probably today that there are other techniques to achieve the same thing. But by that time I was doing this, it was, for me, it was the case that it was the easiest way to achieve this functionality for our setup without changing the whole stack, without reinventing the whole wheels and so on. And then this is how I start Ansible in my case. So I created a function in this DSL, and when I need a build step to run Ansible, I call this function. And it's easier than having things like that. So this is the fancy script which we created with our IT department to start the Ansible. It was like some snippet. And then imagine the case you have the same snippet copied all over the place. And then you realize, OK, I need yet another parameter here or something. It's a pain to go through the whole usages and change it. So instead of that, we're using this function to achieve the goal. Not bad, is it? And this is the declaration of that function. Again, that's something I actually created from my code snippet. It was a natural thing to create such set of parameters here. And what I have at that point, I realized that I have the deployment plan, which is generated by the DSL. And at the DSL level, I have the valid Kotlin program. I have the tooling for me, so I open this project. It generates the POM file, so I can open it in IDE. I have version control. I see what changes are. I can create tests, because this is a valid Kotlin Java program, so why don't I test it? So I'm able to make sure that the configuration, the plan I create, has some specific properties for my setup, so I'm not missing some obvious things. And finally, of course, as long as I have tooling, I can do refactoring. I can see what actually I'm doing, code duplicates, anything. At that point, I realized that the system has to have the regular maintenance. So there is some process which has to be executed regularly. And from the other hand, in TeamCity, I had the buttons to start this process, but it was, well, not that regularly, because some people have to spend their time doing this thing. And it's supposed to be regularly, but as long as the people are involved, it was not that regularly. We are trying to run the maintenance weekly, bi-weekly, bi-weekly, depending on the load and the other tasks we had. So the problem was that's the manual thing, it's called toil, and we're trying to avoid to make it automatic. And from the other hand, we realized that, okay, we have TeamCity with buttons. Why don't we use it to implement the thing? And it turned out to be possible. But the only thing, if you remember the slide with the run configuration, there are some parameters which I need to pass to the system to start doing something. And for that thing, we decided to use Consul. So with Consul, we store all parameters of our deployment in a small key-value database. And then we use these parameters while running deployment to implement the things. So the database was used only for the moment where we do deploy. When the system is running, the console is not used. And it turned out that we have some set of parameters, and to work with these parameters, I created a tiny utility on a Go, which helps to deal with console to read and write parameters in the way I need it. And also this tool turned out to have some assertions saying, okay, I'm trying to switch the stacks, for example, and is it possible right now? The tool is able to ensure that the state is valid and the state will be valid again. And it helps to avoid some failures and issues. So the idea was like this. So we have a plan. We use the data from the database to start the builds. Builds are running on TeamCity, executing all things we need. And once it's done, it updates the console database. And the updates propagates to the load balancer and all the stuff to switch the stacks between. And this is a console template. This is a thing which I use here. That's a tiny, tiny binary from console, which listens to the console database and regenerates the configuration files and kick in some services to restart or read these configuration files. It's pretty easy. It's sort of like an inversion of control. It turns out it looks like an inversion of control. So I change the thing in database, and the whole system is updating. I don't need to run manual scripts. I don't need to run anything to make it work. And it turned out that it simplified the way how we deploy the system. But what if the automagic thing fails? How would I stop it from failing? How would I not break the production while it's running somewhere in the night by the schedule? Well, it is possible. What I do, I avoid switching stacks if something fails in there. And I include some more tests. And what I do, when I set up the second copy of the system, I make sure that the states are the same. I compare states. And only if they are same, then I can toggle the switch and I update the database to change the active system. And it helps. It works really, really easy. So, and the tool which I created, it makes sure that I'm trying to maintain the machine which is not running for some production at the moment. And it is easy to implement with as long as you have anything in the database. Well, the versions update. At that point, I realized, okay, how would I deal with the updates of the system? So maintenance, we more or less can. Updates. And it's turned out that updates are, again, really, really easy because I can create yet another field in my key value storage to store the build numbers. And the build numbers turns into the Docker images. And then I can roll the next version the way I like it. So this turned out that it was pretty, pretty easy to implement. So at the end, I turned out to have the thing like yet another build configuration on TeamCity. So I can pick the version of the system I need to roll. Then I pick the hosts I want to be updated. And then it updates the console database and eventually runs the update in the night. So, and finally, I can create some dashboard or I can see what's going on in there. So as for the sum up, there were several problems which I came across, and it was not possible for me to use other techniques, but the things I have at my hand to implement these things. And it turned out that solving these problems, I was able to set up the pipeline, which is running nightly, every day, and I no longer need to control and waste my time doing some manual things on and on again. It is automated, and just in case something goes wrong, the update is not happening, but the production is still live. So that were like all ops I had, and I hope it was interesting. And well, some technologies I had. And so I want to say thank you for your time. Probably you have questions, or you may tweet me asking your question, whichever you like. Thank you.